Welcome back. The last machine learning classification task in this workshop is using the support vector machine algorithm, which is based on the statistical learning theory. And it has a wide range of applications because it can be used for classification, regression, and anomaly detection use cases. And you can create different models for each one of those tasks using this support vector machine algorithm. I'm going to recreate my data set here from the customers table in my database, and also I'm going to split the data into training and testing and create those matrices which I'm going to use to create my model, my machine learning model. I'm going to use it for classification, and I'm going to use the linear kernel function for this model in order to build the model. And I'm going to train the model using my training data. There are some links there. You can go to check the documentation regarding support vector machine and all the parameters you have for this model, or the hyperparameters you have for this model. And I'm going to see how this model looks like when it is finished. So now it is completed. Its classification. It has the settings here. Most of the settings are default settings. I didn't change anything. The problem I have with model is that the converged value is no, and this means it can be used to make predictions, basically because it has not reached that point of convergence. I'm going to go and change the kernel function. Well, this is the first thing that comes into my mind, just to change the kernel function and make and recreate the model, rebuild the model. And I'm going to use the Gaussian kernel function this time. You can check the documentation here for the kernel-based learning, and I'm going to refit the model with my training data. And I'm going to check again the details of the machine learning model and see how it was created. Again, this is the model classification, the default settings. I didn't change anything here. And this time we can see the model has converged. It means that we can use it to make predictions on the data. And here are the attributes we have provided. Actually, we have all attributes in our customers table, and we can go now and run the model on the testing data to make some predictions and return the first 25 values. So here they are, 25 rows from my customers table. We have the customer ID, last name, first name, and then the actual value which is the pre-labeled information in our data set, and the prediction returned by the model. You can see that there are many predictions which are okay, they're good predictions, but also many results which are not accurate. So I'm going to return now the probability to see how sure is this model about the results it returns in my predictions results. And we can see that this model this time it is actually pretty sure about the values it predicts. So for example, for this value, which is the correct one, we have 86% probability. For the value which is the second one, which is also good, we have 88. For the values which are not accurate, we have low prediction. For example, this one has an actual value of low and the prediction is medium, but the probability is low also. So we can see that the wrong values, let's find another one. For example, this one, which is also wrong, has a low probability. The ones which are good have a high probability, but the values which are not accurate, they have a low probability. So This is a way of identifying how, let's say, how sure the model is, and maybe if that value may be accurate or not by using the probability column and the probability value here to identify, for example, predictions in our results which may not be accurate by using this column. And to actually score the model, we can use the score function, and we can see that this model scores 84%, which is quite okay. Let's say this is an okay machine learning model. And this is it. Thank you very much.